Assalamualaikum, my name is Nurul, Syahira, binti Hudri, and my group member is Daniel, Omar, Nasuha, and Anisyah. Our topic is implementation of survey for Stratum and Spatium in Smart Cadastral. With the rapid development of computer graphics and computer software and hardware technology, three-dimensional Stratum models have become some of the main auxiliary tools for underground resource exploration in recent years. Resulting from the interpolation of the information available in boreholes, cross-sections, or geological maps, a three-dimensional Stratum model is a useful tool for quantitatively representing the extensions of geological structures. After the establishment of the model, the overall situation regarding the geological information distribution in a certain area, especially for abnormal geological phenomena such as missing strata, inversions, and faults, can be grasped. A 3D Stratum model can provide good decision support for geotechnical engineering, coal mining, petroleum engineering, and natural gas exploration. Next is this is our definition for surveying, Stratum, Spatium, and Cadastral. For surveying is the science and art and profession of determining the positions of points on the surface of the earth and measuring the distance, directions, angles, and elevations between them. This data helps accurately create, map, and determine plot boundaries. For Stratum is a survey carried out for the disposal of the underground land as specified under Part 5A, Section 92A of the National Land Code 19,065. The purpose of the survey is for the issuance of a title for a stratum for underground road. So for Spatium is the review is concerned with a multidisciplinary approach to spatial, regional, and urban planning and architecture, as well as with various aspects of land use, including housing, environment, and related themes and topics. It attempts to contribute to better theoretical understanding of new spatial development processes and to improve the practice in the field. For Cadastral, is cadastral data, also known as cadastral, contains official legal documentation concerning the quantity, dimensions, location, value, tenure, and ownership of individual parcel of land. GIS technology is an essential tool for producing current and easily accessible maps, leveraging database information, and automating enterprise work processes in cadastral management. Next is development of technology. The JPM, Department of Survey and Mapping Malaysia, has gone further afield in the way it conducts its cadastral business. It has made a paradigm shift in its workflow by transforming its conventional surveying technique into its current modern system with the help of cutting-edge technology. The evolution of technology has played a significant role in changing the way JPM running its businesses from conventional to paperless and fully automated. As we can see, these are two 2D cadastre such as certified plan, certified strata plan, and certified strata plan, and then 3D cadastre. The concept of 3D cadastre simply defines a 3D lot of having limitation in all three dimensions. This principle means that 3D lot may extend from a specified level and as far into the ground defined by its depth or upwards into the air defined by its height. So, the examples such as 3D conceptual model, Stratum conceptual diagram, Spatium conceptual diagram. Next is Smart Cadastral. The main purpose of Smart Cadastral is to establish a multi-purpose cadastral system for the future with the prime objective of providing a solid cadastral-based spatial analysis platform which supports multi-purpose service towards smart cities.
This project aimed to introducing the concept of stratum and spatium dot with measurement in 3D. The objective of this project are to understand concept and theory implementation stratum and spatium in smart cadastral and to understand how spatium and stratum work in survey. Theory and concept. The concept of 3D cadastral simply defines a 3D lot of having limitation in all 3 dimensions duly registered in the cadastral, providing the right restriction and responsibility of the said 3D lot. This principle means that a 3D lot may extend from a specified level and as far into the ground defined by its depth or upward into the air defined by its height. A 3-dimensional stratum model is a useful tool for geotechnical engineering and other exploration work. The existing method for stratum model construction lack complete topological description of entities, so it is difficult to apply them to 3D geological modeling with complex geometric structure and complex topological relationship between modules. To solve the problem, the boundary representation method is used to represent the arbitrarily shaped geological entities, and the half-wing edge face structure topological structure is processed to describe the topological information of the stratum model for a complex entity. The topological structure can record the topological information of the solid stratum model completely, thereby providing the basis of operation with the model and the application of various algorithms. The reliability and effectiveness of the constructed 3D solid stratum model are verified by an engineering case. The instrument and software that we use to construct stratum and spatium survey: total station, measure tape, A4 paper, and GNSS. For software, AutoCAD, SketchUp, and Google Earth.
And then for methodology, first we need to conduct the stratum survey work, but before that there are some documents that we need to settle. First, application for underground stratum work. For areas that already have ND-CDB fully JTB on Linux, send the following files. For pre-calculated with using ND-CDB, pre-counter should be provided based on DM 2000 coordinates along with appropriate CRM signal notice. And then scanning documents process. This document scanning process serves to save documents into the document management database. The system can search and manage documents based on reference to the measurement file number. These affected documents need to be categorized according to the following categories. And then provision of suruhan perjeluar SKL berdigi. It is divided into 2 ways, which are hard copy measurement plan from land official, digitized PU from the land office. The file for the completed digital SKL must contain at least the following information: folder NDDB, folder PU details, folder SKL, folder CRM, and folder GLMS. And then for the data measurement of transfer of datum from a surface to the stratum layer shall be carried out to determine the planimetric basis of the measurements and coordinate values. Each cadastral measurement shall be based on a satisfactory datum consisting of the cadastral reference CRM is positioned as follows. And then all the measurements in Peninsular Malaysia must be used the Cassini geocentric coordinate system, while the RSO geocentric system is used for the Federal Territory of Sabah. And then for the measurement method, GNSS method, we can use GNSS method. The GNSS observation method can be used for cadastral survey control measurements and stratum measurements. And then measuring stratum lot boundary limits. For planting new border marks, we can use GNSS method. The GNSS can be used to plan new mark based on the coordinates specified in the pre-calculation plan or in the workout trace plan. And then the second way we can use online mark. If a new boundary sign needs to be planted above the old line, sufficient border markings are planted based on the coordinates specified in the pre-calculation plan or in the original work trace plan or coordinates NDCDB. And therefore, the observation required observation, additional information and references made in the field should be recorded in digital form directly from the surveying equipment. For work carried out by JTB, observation data must be digitally signed before being sent online to JPM. And then for the transmission of observational data, submission of observation data must be made online and in the form of JPM ASCII file which contains files such as below. JTB is digitally signed JPM ASCII file, and then the preparation of certified plan. All the necessary information is shown in the graphics shall be generated from NCDB as stated below. First, boundary markers, and for numbered boundary marks, the number shall be shown in a circle near the relevant boundary mark, while the use of terms and symbols shall be in accordance with the procedures prescribed by the Department of Land. And then the lot number, lot area as stipulated by Regulation 38, 3 PK 2009, PN number of neighboring lots, the coordinates value of the two extreme corner marks of the lot to the nearest 0.001 meter, and the last one is the bearing and distance values shall be generated in tabular form and shown to 10 degree for bearing and the nearest 0.001 meter for distance. And finally, to generate the 3D model, we need to use software. The purpose of this model is to provide a 3D view of the physical size and relationship of the stratum loss. Model then underwent georeferencing to enable the model to be loaded in the correct position once imported into Google Earth. To identify suitable software for the modeling process, the following requirements were identified. First, requirement to be compatible with the original survey data format and suitable to complete survey calculation. Second, has the ability to create iframe models from the survey calculation file without significant time implications. Provide and export to the KML format, which is generated from the Google Earth. Fourth, allows for georeferencing to be applied to the models. Fifth, has the ability to view 3D object. And then there are three software programs that were used in the modeling. These are AutoCAD, SketchUp, and Google Earth. Google Earth free software package has 3D rendering capabilities, which makes it a suitable choice for demonstrating 3D integration with existing digital cadasters. That's all from me. Thank you.
Okay, type of data. We use two data, that is primary data and secondary data. Okay, we are focus the secondary data, that is GNS method. Process all data. There are three software programs that were used in model process. First, AutoCAD, SketchUp, and Google Earth. Okay, AutoCAD. It is common software platform used in surveying industry and is available for use throughout the research project to measure distance, angle, height, and coordinate. The original data being used to create the model was originally calculated using AutoCAD. So maintaining the software reduce conflict of data through conversion. The process of measurement of cadastral land plot research by Google Earth and tachometer instrument, as well as demonstrate how software can be used to process field survey measurement and draw a cadastral plan. Okay, next, Google Earth. This software can control point measured by Google Earth, can be used as start and end points of the station traversing. Measurement differential or relative position to base station are required. They can be represented in a graphical form to draw parcel boundary with dimension derived from the Google Earth coordinates. The use of Google Earth as a final presentation allow the model to be analyzed in the same environment. So you can see this line in our map in Google Earth. So this line we create in AutoCAD and then we put in Google Earth. Okay, next, SketchUp. Sketch model can be drawn into and displayed in Google Earth with full reference to its surrounding. At this stage, auto test, the software developed of AutoCAD products does not allow direct export to the KML format. Font is product, however, third-party software add-on are available to include this export feature. For general user, SketchUp provide an easy way to do 3D modeling. So we are now sketch for 3D modeling. Okay, this is output. This is example. Okay, next, this is example 2.
So for the planning of works, for the requirements of a pre-stratum or pre-spatium measurement, we need to have the certified plan, which can be obtained from Japan, certified stratum plan also from Japan, and we need to obtain the datum since we deal with heighting or altitude. So in the sense of assessing the land class that have been determined by law, in this part we need to understand what is minimum depth. Minimum depth were the parameter that bounds in what depth does the owner is allowed to apply ownership, which is specifically over the stratum. According to section 92B and section 92E, for agricultural land 6 meters and below are considered eligible to apply stratum. For buildings that are 10 meters and below, you can apply stratum, and industrial lands can apply stratum under 15 meters. So next, according to section 92C, given ownership of underground land, stratum under government owned land, if you can see the top one, the green surface, is the government owned land, and below it is the underground stratum that would be allowed to apply ownership. And below the stratum eligible ownership, it is considered as government owned land. According to section 92B 1A, section 92D 1B, the owned land that were not depth specified under it, which is eligible to apply stratum ownership, and below the stratum ownership eligible stratum, we can consider the land to be government owned land. Next is section 92B1A, section 92D1A. With the owned land without depth specified on the surface, whilst we got depth to be specified by state authorities below at the right. And on the left part of the land that have been approved for independent and unrelated use, which is on the left, the near beige color, and on the right bottom is considered as government owned land, as well as on the left side bottom of the layers of ownership. So these are the specifications that we have to follow, and thus they have many more specifications in terms of stratum owned land.